Hello, everybody, and welcome to MajorDom's 17th DePIN workshop. Today, like you already can see, and I think you already know, we will look into how we can use the knowledge, or some parts of the knowledge which we already used in the last workshop, which depends on interacting with RagFlow, as well as the Moonchain API. And we will use this knowledge today to create our own AI doctor. You can find you can find this tutorial in the Moonchain docs in the testnet tutorials. Build your own AI doctor using Moonchain, RagFlow, and Wi-Fi. Before I will want to go on with this topic, I need to introduce you about some changes which have been done on the RagFlow demo, the online version of RagFlow. So because they use a new version there, the workshop for the LLM reporter won't work in the way anymore, like I showed it in the video, because RagFlow demo, I can show it to you actually, won't provide an API key for the assistant anymore for us. You can see it here. Normally, if we click here and would click here, we would be able to get the API key and the API address, the URL for the API call. But sadly, like I said, because they changed it, I wasn't able to use it in the German workshop on last Friday. So I had to figure out and make it possible to run it locally. For this, I started to take the approach of using the WSL on Windows 11. I would not want you to do it this way because it took me around 2 days and I'm still not fully figured out what was the problem when it came to CPU usage, memory usage, and indeed how to get the connection. So we decided to use VirtualBox instead to run the Docker container. The Docker container you can find here in this repository. I also provided it here in the tutorial description itself. There, I also need to tell you it would be impossible to change the .environment file. I can show it to you how it's done, actually. I hope I can do it a little bit bigger here. Yes, it's working. So we will open a new tab, which is small again, sadly. So RagFlow, Docker, and here we have the .env file. And here it would be necessary in the beginning, when you open the file, it would be, or it will be like this. Only showing Slim, or I just see that I didn't recommend it Slim. But it worked like it was intended. I think it's because, yeah, the other image just overwritten the previous, and because of this, the version 11 was installed. I've written in the tutorial that you should use version 12. Actually, version 11 and 12 both worked, like I tested it now. Version 10 didn't work like I wanted to use it, and the latest version also didn't work like I wanted to use it. So, yeah. Additionally, you would need to create your own Gemini key, because Gemini would be the API which we will use. This you can do via using this link. But I also want to explain you that you need to have a Google account to use it. Sadly, because I had so much issues when it comes to CPU usage and memory, also when I used the virtual machine, I won't do the whole preparation in the workshop today, but I think I explained everything pretty much here in the tutorial, so everyone should be able to follow. And if not, please leave some comments or question under the video or also in the Moonchain MajorDom channel. So under the video, there should be the link to the Moonchain channel, and in the Moonchain channel, we have an own MajorDom channel. You can ask there, or yeah. With this said, I would like to begin with the creation of our project. Like you see it here, we would start with creation our folder, which is already done. The next step will be to initiate our npm project. Fine. Was a little bit. I wondered why there's an output in this way. I kind of had the thoughts that it would be some kind of different format. These libraries we will install, so we are able to directly use the script as TypeScript. What is this now? The typo here. Types, no, it's safe to have TypeScript, JavaScript, and PN install. For sure, there's a typo once again. So note that it works properly. The next step would be to initiate an npx DSC project, so a TypeScript project. This we are doing now, and so here you can see the folders which are just have been created. So we want to go on. The next step I want to show you is the installation of the needed libraries or dependencies. We will use ethers, sure, because we want to interact with EVM-based smart contracts. We also need Axios because we want to do HTTP calls. The next library will be zlib to be able to decompress our broadly data, which is the transaction data of the health data we will use today. So analyze kit. And the last one is a library which we can use to further format the health data, because I think if you looked so far in the other tutorials which we have done on this Plotly topic, then you see that even the uncompressed format is not easy to understand for humans, but as well for AIs. So we are using this library to further format this data until we use it. And yeah, with this said, I would say we will go over to create our first script, which will be the query events.ts, which is also explained here. Collect data from Moonchain. The first step would be to implement the data source as well as to define the API. We use this contract address as well as the API you can find here in this link. This is the API we will use for this. This only the API for the specific claimed event. And yeah, I would like to not fully type the coding parts, but to copy them today, because sadly I don't have that much time until the workshop needs to go online, and because of this, yeah, I need to go this approach. But for everyone who is interested in the full code, you can find it in the you can find the scripts for the steps in the last line of the specific step, but you also can find a link to the whole repository inside of here. I think or do I need to edit? Yeah, I think I actually need to edit. Oh no, here I already edited, so you can see all the yeah, points which are, or all the scripts which we used. You also can find the knowledge base which is necessary to prepare RagFlow, or to make it easier for RagFlow to get us health specific responses. Yeah. With this said, we are already created the provider. Provider is for sure our RPC, and then we use the JSON RPC provider function from TypeScript, from JavaScript, from the ESES library to create a provider. The next line is the setting of the contract address we will use. Then, of course, we have to set our ABI. Just will copy this and paste this also. Make it a little bit larger. I hope it's better now when it comes to being able to read the parts I'm writing here, because when I further looked into the already done workshops, I thought when it came to looking onto maybe mobile phone or something like this, or looking them on a mobile phone, it could be hard. It could be hard. So, but with this steps done, currently we are able to create our contract object, which is this. For this, we are, like I said, we provide the provider, the ABI, which I just introduced or implemented into the code, as well as the contract address. The next step, which I want to show you, will be the decompress broadly algorithm, or the decompress broadly function. For sure, we at first have to decompress or dechiffre the content, because it will be base 46 compressed. And when this is done, we are also able to decompress it via broadly decompression, and then we can return the decompressed buffer data. And our next step will be to create our track claimed events function, which is this one, which provides a promise with the token ID, the content, and the timestamp, and takes the block number from a 2 to create, or to get the searched events. For this, we will also use this filter, because for sure we only want the transaction which have happened on this filter, on this contract, sorry. And for sure, we only want the transactions between the from as well as the to block, which will be, like I said, be a parameter when you call track claimed events. Sorry. So the next two parts are more to get logs and print them out. Then next we will create a transaction object, or an array of transaction objects. And in the next step, okay, here we don't get the logs. Sorry, we call the transactions which are fitting to this filter. And with this part, not this part, sorry. With this part, we are iterating through each of these transactions and pass them, and get the token ID, the memo, as well as the timestamp, and write these into parse memo. Then, of course, we have to decompress the content. Sorry. For sure, we have to call the already written, already created function for this. And with this done, we then push our found transaction into our transactions array. With this done, actually, the first step of our tutorial is already done, which would be collecting data from Moonchain. I would like to go on with step 2 and 3 because currently the scripts are handled in this way or created this way that they are started by or handled by the third script, which will be our main script. And yeah, because like I already said, so much time is not there anymore until I have to upload the workshop to be able to make it until 15 o'clock German time. So yeah, with this said, I would like to just go over to our next script, which will be our RagFlow sender script. For sure, once again, TypeScript script. Here we know we'll need Axios as an import. The next step will be to set our API address. Please don't wonder about that. I don't use localhost here, like I explained it in the tutorial. Like here, this 127.0.0.1 is nothing else than localhost. The most people which are looking this will know this, I think, but for the people which didn't knew it already, it is like it is. Another localhost address would be 10.10.0.1. No, it's not localhost. It's only a local address, I think. So I don't want to go too deep into this topic, and maybe even tell you something wrong. You are now providing the variables you will need to interact with our local RagFlow implementation. Here you can write every string, every value. It's just for giving the RagFlow model the opportunity or the possibility to track the conversations which are coming from the same user. And yeah, our user ID in this case will be your user ID here. So yeah. We are now create the function which would actually send the data to RagFlow, which we want to use. The first step for this will be to create a specific question, which we will send to RagFlow additionally to the data. So here you can see what we will ask it. You're a professional health advisor. I'm the owner of token ID. Will be the token ID is a parameter which will be set in. Based on the following health data from the past week, please provide a personalized suggestion. Health data start. Here we will use the parameter, the data as parameter, and yeah, data stop. So the LLM understands. Okay, here will come no further data after this. Once more, we will log it on the terminal just for convenience, I would say. In the next, we try to get a conversation. For this, at first, we will create our URL. Here, I want to mention one further thing. In the tutorial or in the RagFlow user interface, it's currently the case that the URL has a slash at its end. I think it's not necessary because I set it here, but you have to think about it. So if we would set it here, would set it here, then I think we have to delete it here. I'm not sure if it will work, if it would be doubled. Anyways, like I said, we created here our URL, which we will call. Here we have our header, which we will provide when we call this URL. Then we have here our response object, hopefully, or we are awaiting our response object. And then we are looking into the first data object, the data object in this data object, and we are looking for the ID in the internal data object, which we will write into conversation ID. And this conversation ID we will use further. Before we can do this, we'll implement a check if we all have a conversation ID. Otherwise, we directly provide an error onto the terminal so the user understands that there is an issue. Yeah, and with this said, I would like to now create the post object, which we will, or the post data, which we will use to interact with RagFlow. So as soon as we have gotten this conversation, we need to switch the URL and use the completion model or the completion URL. For this, we will use the conversation ID. The conversation ID makes it possible that we can have a conversation with our model, which we just introduced with calling new conversation with our user ID. And with this done, we will provide this into post data. In the message, we will once provide our role as well as the question, which will be not only the question, but the question with the inside health data. Yeah, and then next we will wait for getting the response to this call, or we do the call and wait for it. It's kind of the same in this line. And yeah, because currently it's not working that we switch the stream onto false in the post object. We have to work with a buffered approach to track the right data. For this, we additionally will provide timeout. So in terms of if in 60 seconds we don't get any response, then it also will be provided an error. And the next step will be to actually use the buffer data, which will be a long part. And for me, it would be kind of hard to explain it to you, but I will try. So we are writing a new promise, which we get from the completion response. The data or every chunk we get from there will be buffered and added to the chunk. We use the toString method on this chunk and then append it to buffered data. We will split the buffered data every time when we have this sign, which means there should be a new line. Sorry, my English is not perfect for explaining this. And if the line is not completed fully, then we will also took this line because we were expecting that the buffer not full ended this line. So we have to add the missing data to it. So here we will using only the fully lines. Here we will trim them from multiple data keywords, and then we will pass it into this JSON data object. And yeah, in case the data stream ended, we will delete the timeout and use and check if there's data in the buffer, in buffer data, and if so, we will further process this data also. And our last part begins here. So here we check if there have been any error. If so, or if there haven't been any error, and then we will print the whole answer. Otherwise, we will have to print that there have been an error. And in case there is an error, then we will call this function further. I'm not really happy that I wasn't fully able to deeply explain every line step. We have to look into this buffered streaming data once more to fully understand how it's operating. But for now, I know it will be I know it will be working, and want to focus onto the next our last script for today, which will be main testing.ts. And this we have to import a lot more files for sure. We have to import the two files we already have written. We then have to import a readline, which is more. It wasn't actually necessary, but I wanted to implement it that we are able to read inputs from the terminal. And yeah, for sure, we also wouldn't need ethers and the do-it-ring analyze kit, which I talked about, to better be able to order the data, to clean it up, to make it understandable for humans, make it more readable. Yeah. We will wait for the current black number, which we will call automatically with the ethers library. We then ask for the token ID, which will be no, sorry. We check the claimed events, which we will write into the transactions object, and then we will ask for the token ID, which will use readline to call the input of the integer from the terminal, which will be done here. So error on question. This is the input token ID, which gets called from the terminal. And with the next part, we are parsing the transactions, which we already called, and searching only for transaction with this specific token ID number. So we are only using the health data of this specific NFT or this specific Wi-Fi object or Wi-Fi product. Here we are currently, like I said, parsing the content, and we use the we are creating a flat map of it. And in the next step, we then will use the the do-it-ring analyze kit to further order, not order, sorry, it's not order what I want to say. It's also not clean, further tidy up the data, like I said, to make it more readable, not only for humans, but also for the LLM on which we want to send it. So yeah, here we have the flat map. Flat map is also something I further have to look into. With these 3 lines, we get the actual date of today, as well as the date of the week begin. For this, we also call the timestamp, print it into the terminal, and group our data for this timestamp. So we're only calling data with these .ring analyze kit that is specific for the work for the week with this timestamp. So for this, we get the object weekly group sleep data. And this weekly group sleep data, we further have to process with groupings daily, because when we want to use the sleep data for getting insights out of it, we cannot use the weekly data. We have to use the daily data to further to get insights for every day, because otherwise it won't be working like it's intended to do, and will be inefficient, and the quality of the response will be pretty bad. So here we will add everything of the data, the health data, and append it onto the health data object. So the first line will be the day number, the index of the day, then the sleep analysis, then how much deep sleep the person had on the day, light sleep, REM sleep, and the overall sleep score for this day. And this will be done for every day of the whole week, for which there is sleep data available. And yeah, then we also can further process the other health values, which will be the step analysis, the oxygen values, as well as the heart rate analysis. Sorry. And yeah, with this done, we will check. Here it's not necessary to do it daily, because you just can append it or you can edit to another, or you can calculate the median from all the week's data. But when it comes to sleep data, it's not that easy. We also will add a check if the needed value is actually there, and if not, we won't use it. And yeah, with this done, we are actually pretty much done with this code. Just this part, we will have here once more a console log, which we will use, and then we send the health data, which we just created with the token ID, because this we also give through to the LLM. Yeah, and as soon we get a response, we also will close the readline object, and we will create a new readline object, which also makes it possible to call health data for another token ID. At the last, we only have to add the get current block number function, which we already used and I've told you about, I think. And our last line will be error catching and preventing putting these errors out on the terminal. And with this done, I think we're actually pretty much able to call our AI. I would like to start or make sure that the AI is running. So I'm sorry that I had to stop the video for some time. And I also had to re-upload the video. I just looked into the workshop, and sadly, because it was the first time to not only do a workshop, a live workshop, but to use pre-recorded images or pre-recorded video parts, and then switch from the pre-recorded video parts to the live stream. This I tried to use to be able to provide the workshop today in time, or in terms kind of in time. Sadly, when I looked into the workshop video, I just found out that I used different audio streams. The one which I wanted to use, and also the audio source which was from the old recording. So it's pretty hard to understand what I'm saying in the second half of the video, at least. And because of this, I want to further produce or further create a second workshop video, which I will re-upload in not as a live stream, but as a normal video. And I will reference to this video in the description of the live stream. I just figured out that while I was setting up the project, I didn't fully did it the way like it's shown in the Moonchain docs. And because of this, I had to further install the Do-It-Ring Analyze Kit, which I was talking about further. So we can pre-process the transaction data or the health data. And yeah, with this set, I just check if the virtual machine is still running, which is fine. And with this done, we are now able to run our script. So the next output should be, yeah, exactly this, tracking the first block, or tracking every block from the 0 to the current block. Then what you can see here is all the transaction data, which is depending to the event which we are calling, or these are all the transactions which are interacted with the event which is interesting for us. And we can now choose a specific token ID. For testing, I mainly chose token 89. Not sure which token it is, but it provides good sleep data for every weekday. Some tokens only have sleep data for a part of the week, and it's also providing walking data as well as calories, which has been burned via these steps have been made. And also the blood oxygen level is there. And here we can see our response perfectly. We can check that the values which are used here are the same like here, and the kilometers are fine. So this is the health report like it was intended from us. And here we get some personalized suggestions from the Gemini model, how we can further improve our health. And yeah, we can feel better, get better sleep, feeling fitter and stuff like this. I also want to show you a different token so you can see that it's not hard-coded or something like this. Yeah, here you can see that the walked distance is definitely another. The burn calories are also different. In terms of the sleep data, token 15 also, no, token 15, is it 15? Yeah, 15. Token 15 also provides sleep data for all the 7 days of the week. I'm just saying this because I already have seen some tokens which are only providing data for like 4 days or something like this. Okay, this one not. One thing I also want to mention is another important part when it comes to the RagFlow configuration and for getting the whole output of the model. So while I was testing the model output and have been struggling with the YouTube stream, I just got one response when I only used 512 tokens, and the other response was cut on the end. So since I decided to set up the max token count to 1024, the responses and the answers we get so far are totally fine and are not cut on the end. Here you can now see what I was talking about when it comes to calling the data of the last 7 days and only getting part of a part of the data, which would mean that the user didn't use the health at his Wi-Fi device on the other days, or at least he didn't claim the data or provide the data and claimed a token for this. Yeah, with this said, I now will create the second video, and I will soon upload it, so you don't have to bother with the work with the live stream and the bad sound which is ongoing there, because like I said, I still have to figure out how I can switch between recording and live stream while I'm live on stream. So yeah, with this said, I hope you enjoyed what you have seen today. I also would love if there would be some further questions. If you just write them under the video. It doesn't matter if it's the live stream or the new uploaded video. Or you also can reach me or can contact me via the Telegram group from Moonchain. There we set up an own channel for the MajorDom workshop. And yeah, I think the best source and the fastest source to get in touch with me would be to try it there. The link to this should be also in the description, so you can find it there. And yeah, with this said, I hope you have fun doing this project and using the knowledge you got from today for your own projects. And yeah, happy coding and have a happy weekend. Thank you for now.